Hello dear friend, good morning. Let us see lecture number 3, chapter number 5. Last time we were discussing continuity of a function. Let us see more examples today. Here. Okay, last time we solved this question number 7. Today I would like to solve this question. For what value of lambda this function is continuous at x is equal to 0? And what about continuity at x is equal to 1? Now see here. We need to find left hand limit and right hand limit to check the continuity. For which value of lambda? Here. First of all, try to check the continuity at x is equal to 0. Limit x tends to 0 plus f of x. Why am I writing left hand and right hand limit? Because of inequality is given here. So find out right hand limit. Limit x tends to 0 plus x greater than 0, then 4x plus 1, and that comes out 1. Next, left hand limit. Limit x tends to 0 minus fx is equal to limit x tends to 0 minus lambda of x square minus 2x. Lambda is constant, so lambda into x tends to 0 minus x square minus 2x, and that comes out 0. Lambda into 0, 0. See, right hand limit exists, left hand limit exists, but they are not equal. And therefore, what we see, limit x tends to 0 plus fx is not equal to limit x tends to 0 minus fx. Right hand limit exists, left hand limit exists, but they are not equal. So limit not exist. And therefore, limit x tends to 0 f of x does not exist. So function is not continuous. Therefore, what we have to write? And therefore, function is not continuous at x is equal to 0 for any value of lambda. You can take whatever value of lambda, but left and right limit exists, but they are not equal. So this one is not continuous for any value of lambda at x is equal to 0. Next, what we want to see, same question. What about continuity at x is equal to 1? At x is equal to 1, see here. At x is equal to 1, we have to check that fx is equal to 4x plus 1. That is independent to value of lambda. Limit x tends to 1, f of x is equal to limit x tends to 1. Put the reason. X is equal to 1. X is equal to 1, which is greater than 0. So what we have to write? 4x plus 1. See, fx is equal to 4x plus 1 if x greater than 0. So that comes out 5, and that is also f of 1 because f of 1 is also 5. F of x is equal to, we have to take 4x plus 1 when x greater than 0. So 1 is greater than 0. So what is f of 1? 5. So what we proved? And therefore, limit x tends to 1, fx is equal to f of 1. And this one is for all lambda belongs to R because it is independent of value of lambda. So, for all lambda belongs to R, f is continuous at x is equal to 1. Clear? See, this is the question that we want to answer. Let us see next one. See, yes, what is this part? See, here it is integer part, let us integer part function is given to us. So that this function defined by is continuous at all integral values, integral points. Now see, first of all we need to note that n less than or equal to x less than n plus 1 imply this integer part is equal to n. Integer part function is n. That we know. Now, therefore, for all n belongs to z, find out limit. Why am I taking left and right limit? Because integer part function is f of x is equal to limit x tends to n plus means what? N less than or equal to x less than n plus 1. Means here it is given n less than x less than n plus 1. This says that integer part function is equal to n. So here what we have to write? X minus integer part x, and that is equal to limit x tends to n plus x minus n because of this reason. There. So that is equal to, what is this limit? X tends to n. So n minus n. That is 0. Is it clear? See. That we have to check at all integral points. That means for all n belongs to that. So right hand limit x is that is 0. Let us try to find left hand limit here. Limit x tends to n minus fx is equal to limit x tends to n minus x integral part x, that is equal to give region. Here x less than n. So here that should be n minus 1. So this says that what is integral part x? That is n minus 1. So limit x tends to n minus 1. So what is this limit? N minus n plus 1, that is 1. So right hand limit exists, left hand limit exists, but they are not equal. So what we see? And therefore, here x tends to n plus fx is equal, not equal to limit x tends to n minus fx. So both limit exist, they are unequal. Means limit not exist. And therefore limit x tends to n f of x does not exist. And therefore, yes, what? F is not continuous at every n comes to z, and that we want to see here, so that this one is not continuous. 20th very simple example. This function is continuous at x is equal to pi. Fx is equal to x square minus sin x plus pi. Find out that limit. Limit x tends to pi, fx is equal to limit x tends to pi. What is fx? X square minus sin x plus pi. This one is simple ordinary limit. What the value? Pi square minus sin pi plus pi. What is sin pi? 0. So So that is pi square plus 5. And what is f of pi? Same as to this one. Pi square minus sin pi plus 5 because fx is this one. So that is also pi square plus 5. So what we see? And therefore limit x tends to pi. What we proved? Limit x tends to pi. F of x is equal to f of pi. And therefore f is continuous at x is equal to pi. Clear? That we want to see for the second part. Now what is the third part? Here. We know that sin x and cos x both are continuous. One liner question. Sin x and cos x both are continuous functions. And we know that sum of two functions, sum of two continuous function is continuous, difference of two continuous function is continuous, and product of two continuous function is continuous. And therefore, fx is equal to sin x plus cos x is also continuous, and fx is equal to sin x minus cos x is also continuous, and fx is equal to sin x into cos x is also continuous. And we already seen this continuity of cos function, cosec function, sec function, cot function, tan function, sin function. Last time we already seen all the continuity of these functions. Today let us see next thing. Find the all points of discontinuity of this function. Function is given this one. Now see, for x less than 0, fx is nothing but division of two continuous function. So it is continuous. Also, for x greater than 0, fx is nothing but what? X plus 1 is a linear form, is also continuous. Now our aim is to see continuity at 0. And at 0, three parts are there. Greater than 0, less than 0, equal to 0. So we have to check the continuity at 0. So check it. Limit x tends to 0. Plus fx is equal to limit x tends to 0 plus, what is fx? Whenever x greater than 0, x plus 1. So that comes out 1. And next, left hand limit x tends to 0 minus left hand limit fx is equal to limit x tends to 0 minus, what is fx? See here. X less than 0, then fx is sin x by x. And we know that this limit is 1. So right hand limit as well as left hand limit both are 1. And what is f of 0? F of 0 is also 1. X greater than or equal to 0, then fx is equal to x plus 1. So that is also 1. So all are same. And therefore, see this right hand limit is same as left hand limit is same as f of 0. So if you want to write one column, you can write it here also. Therefore, limit x tends to 0, f of x is equal to f of 0, and then f is continuous and then is equal to 0. What we want to prove? Find all points of discontinuity of function.
This one is continuous for all x belongs to I. So there is no point of discontinuity is there. Determine if this function is defined by this function is continuous function or not. X square sin 1 by x here. Fx is equal to what is given to us?
f of x is equal to x square sin 1 by x. X not equal to 0 whenever x is equal to 0. For x not equal to 0, fx is product of two function is continuous. Clear? At 0 it is constant function, that is also continuous. Now we have to check the continuity at 0. For this one, let us recall one result. This thing is already seen in 11th sandwich theorem. This says that whenever there is a relation between such three functions, likewise this one, for all points in domain, and if this one and first and last function have a same limit, say L, that is, then the limit of middle one is also L. So this is the sandwich theorem. Here only two particular examples are there for which we need to use sandwich theorem. X square sin 1 by x or x square cos 1 by x. Okay. So let us use it here. We know that minus 1 less than or equal to sin 1 by x less than or equal to 1. Yes or no? Yes. So multiplied by x square on both sides throughout. Multiplied by x square. And order sign remains as it is because we know that x square is not negative. Also note that these two functions have a same limit at 0. Yes or no? Both have a same limit. And therefore, by sandwich theorem, limit x tends to 0, x square sin 1 by x is equal to 0. That is, limit x tends to 0, f of x is equal to 0. And that is also f of 0 given that. See? If x is equal to 0, then fx is 0. And therefore, what will we do? And therefore, f is continuous, but x is equal to 0 also. So this function is continuous. For x not equal to 0 is continuous function, and at x is equal to 0 also continuous function. So continuity of this function is there. See, this one, both functions are continuous. Next, here, exam continuity you have defined by this function. See? What is given? X not equal to 0. For x not equal to 0, f of x is difference of two continuous function is continuous. Next we need to find continuity at 0. For x tends to 0, f of x, here ordinary function, so we have to take direct limit, there is no need to take left limit and right limit. So limit x tends to 0, sin x minus cos x, sin 0 0 cos 0 1, so that is minus 1. And note that f of 0 is also given minus 1. And therefore, limit x tends to 0, f of x is equal to f of 0. And therefore, f is continuous when x is equal to 0 also. Very simple question. Next. Hey. What is given? If these functions are continuous, then find value of k. Find value of k if following functions are continuous. Now see, this type of sum they are going to ask for multiple choice questions. So directly I am going to answer. See, here inequality is there? No. So directly. Limit of this one we want to find. See, k common from numerator, 2 common from denominator only. That is limit x tends to pi by 2 fx. But see, as far as multiple choices question is concerned, we have to see directly how. See, this limit comes out k common. Take 2 common denominator quantity. What is numerator? Cos x. Can I write that is sin pi by 2 minus x over pi by 2 minus x? Can I write it? Yes. And now this limit is 1. So that is equal to k by 2. And it is continuous at x is equal to pi by 2. So that is equal to 3. So k is equal to 2 into 3, and that comes out 6. Here, see, here what is given? At x is equal to 2. Left hand limit is 4x, left hand limit is 4k, x is equal to 4k, and right hand limit is 3, and that is equal to also 3. So what is k? K is equal to 3 by 4. Same way here, at x is equal to pi, what we get? K pi plus 1 for this one. For x greater than 1, for x greater than pi is cos pi. And what is cos pi? Minus 1. So what we get? K pi is equal to minus 2. Implies k is equal to minus 2 by pi. Yes or no? Very simple things. So this type of example they are going to ask for multiple choice question. Find the value of a and b. If it is continuous, at 2 limit is pi. Less than 2 pi, greater than 2 then 2a plus b, one relation is there. Continuous at 2 as well it is continuous at 10. If continuous at 10, then what we get here? 10a plus b is equal to, for greater than 1 it is 21. So we get two relations. From here what we get? B is equal to 21 minus 10a. Replace it here, then you get value of a. Substitute value of a here, then you get value of b. Very simple thing. So this type of question they are going to ask for multiple choice questions. Find the values whenever the functions are continuous. Directly we can answer it. Next. See here, this type of sum we already seen. Yes, how composition of two continuous functions is continuous. We already seen sin x square. So here cos x square. For this part, what we have to take? Fx is equal to 0 h at x. Gx is equal to first function cos x. Hx is equal to second function, that is x square. These two functions are continuous and the composition of two continuous functions is continuous. So it is continuous. For this one, what we have to take? For this part, same way, fx is equal to hog, or you can take any one, hog at x. Hx is equal to first function, that is modulus x. Gx is second function, that is cosine x. Once again, composition of these two functions are continuous, and the composition is also continuous. And for this one, what you have to take? Fx is equal to, you can take any two functions, but I am, for simplicity, I am taking hog. First function hx is sin x, second function gx is equal to mod x. And see, these two functions are continuous, and composition of two continuous functions is also continuous. And number of sums you already seem to find the point of discontinuity. So I am leaving this one for you. Homework. Here? Yes. Next. Yes. Now, important thing. In 11th science, we already seen this definition, differentiability. Function f is, suppose f is real function and c is point on its domain, the derivative of f at c is defined by this function. Here. And that is f dash x. But let us see here. In general, what we have to see. We already noted standard forms in 11th science. Let us recall all the standard forms one by one. First of all, I would like to write definition. d by dx of fx, or we can say it is f dash x also. That is equal to limit t tends to x f of t minus f of x upon t minus x. So in 11th science already seen this point. Now if we take t minus x is equal to h, implies t is equal to x plus h. Also t tends to x implies h tends to 0. Clear? And therefore, what can you say about f dash x is equal to, or otherwise d by dx of f of x is equal to limit h tends to 0 f of x plus h minus fx upon h. Why? Because t is equal to x plus h and t minus x is equal to h. So this is the definition of derivative. Here, see, this one is known as derivative of function f with respect to x. And the process of finding derivative of a function is known as differentiation. At all, we are not finding differentiation. Differentiation means is a process to find derivative of a given function with respect to given value. Okay? Yes. Using this standard form, using this formula, we can see the standard forms of differentiation. See, I would like to write one by one standard forms. First of all of you are known this form x raised to n is equal to n raised to n minus 1. Yeah. Now, see, if I take y is equal to sine square x, is a product of two function and is also a composition. F of x is equal to, if I take x square, and gh is equal to if I take sin x, then what is f of g at x? F of g of x. What is g of x? Sin. What is f of something? Something square. So it's a composition. So how to find the derivative of a composite function? See here. If I write y is equal to f of g at x, then derivative notation is we are taking d by dx on both sides. So dy by dx of f of g of x. Yeah. So rule says that first of all derivative of first function, second one as it is, into derivative of second, g as x. So this is the derivative of composite function. So we have to remember all these standard forms in a composite form. So how to write it? Composite form of all forms here. Remember this form as a d by dx of some function raised to n. Some function raised to n. That is equal to n times some function raised to n minus 1 d by dx of some function into derivative of first function some raised to n. So first of all that derivative into d by dx of whatever may be function here. See, then take, see, let us consider one example. D by dx of if we wish to find sin cube x. So first of all, derivative of cube power x cube. So that is according to this form 3 times sin raised to 3 minus 1. That is sin square x into d by dx of sin x. Some function raised to n is equal to n times some function raised to n minus 1 d by dx of some function. And what is the derivative of sin x? That is 3 sin square x into cos x. Okay? So in this way we can use this form. So let us write all forms of this form. Then some rules are there. See. Now from this standard form, frequently we are going to use 3 other forms. But let us particular 3 forms are there. Take n is equal to 2. So d by dx of x square. According to this formula comes out 2x. See, how we are going to use it? D by dx of some function square. That is equal to 2 times some function d by dx of some function. Suppose we wish to find d by dx of cos square x. How we find it? Something square. 2 times something into d by dx of cos x. And we know that what the derivative of cos x is minus sin x. Yeah. So in this way we are going to use that forms. So now I am going to give particular example. First of all, write down all the standard forms. See. Now take n is equal to minus 1. So d by dx of n is 1 by x, take n is equal to minus 1. Minus 1 x raised to minus 1 minus 1. So it comes out to minus 1 upon x square. Now this implies d by dx of 1 over some function minus 1 over some function square d by dx of some function. Clear? Now take n is equal to half, that is root x. Take n is equal to half, that is root x. What what is derivative of root x? Take n is equal to half. Half x raised to half minus 1. So half x raised to minus half. So half into 1 over x raised to half. That is 1 over 2 root x. So what is root something? 1 upon 2 root x. So we would like to see this thing, derivative of d by dx of root some function, that is equal to 1 over 2 root function d by dx of some function.
So these are the three algebraic forms that currently we are going to use it well as far as problem section is concerned. So, and these three forms are derived from this one. Here. Next, now exponential forms are there. What are the exponential functions? We know that d by dx of a raised to x is nothing but a raised to x log a base. So how we are going to use it? How we are going to remember it? D by dx of a raised to some function, a raised to some function, log a base d by dx of some function. Suppose we wish to find derivative of 7 raised to x square. D by dx of 7 raised to x square. A raised to some function, log a base d by dx of some function. What is derivative of x square? Last derivative, right? First. 2x 7 raised to x square log 7 base. In this way we can find it derivatives. Yes or no? Next, d by dx of e raised to x, exponential function. What is d by dx of e raised to x? It is nothing but e raised to x. So we are going to remember it. E raised to some function, e raised to some function, d by dx of some function. Then logarithmic form, d by dx of log x or d by dx of log of magnitude x. That comes out 1 by x. Derivative of log x is 1 by x. So how we are going to use it? D by dx of log mod something or d by dx of log some function. That is equal to 1 by some function d by dx of some function. Clear? So this is the three exponential forms are there. And these are the algebraic forms. These are the algebraic forms. Please, most important information for you. Please learn all these standard rules in form of some function. Then only you are going to solve easily all the sums based on differentiation. No problem at all. Clear? So please learn all these forms for upcoming lectures. See here. Now let us move on our trigonometric forms. 6 trigonometric forms are there, and that we know very well. What is the derivative of sin x? We know that it is cosine. So how are we going to remember it? D by dx of sin some function is equal to cos some function d by dx of some function. Now d by dx of cos some x is nothing but minus sin x. We already seen all these forms in 11th science, but we already seen only a single variable x. That means single functions are there. As far as 12th is concerned, we have to see composition of functions. Yeah. So next one, d by dx of cos some function, that is minus sin some function d by dx of some functions. Clear?
Now see, d by dx of tan sum is nothing but sec square. So d by dx of tan sum function is equal to sec square sum function d by dx of sum function. Next, d by dx of cot x is nothing but minus cos x square. So this implies d by dx of cot sum function is equal to minus cos x square sum function into d by dx of sum function. Then d by dx of sec x. What is this derivative? Sec x into tan x. But how we are going to remember it? D by dx of sec sum function is nothing but sec sum function, tan sum function, d by dx of sum function. Then d by dx of cosec x, that is minus cosec x cot x. How we are going to remember it? D by dx of cosec sum function is equal to minus cosec sum function cot sum function d by dx of sum function. Okay? Now you can see that these are the 6 trigonometric forms are there. 6 trigonometric forms are there. Keep one thing in mind. A function starting with c have a negative derivative. See? Okay? Same way 6 inverse trigonometric forms are also. So let us say that forms are. Keep one thing in mind. Function is differentiable only on open interval. Function is differentiable on only on open interval. Now see, y is equal to, consider f inverse x. Can at x is equal to f of y? Yes. Before that thing, let us see first of all notation of derivative. See, if y is equal to fx is given, y dash is notation for first derivative, y1, or we can write f dash x, or we can write d by dx of fx, or we can write dy by dx. These all are the notations for the first derivative. Notations for first derivative of a given function y is equal to fx. They can ask for y is equal to fx, find y dash, find y1, find f dash, find d by dx of fx or dy by dx. One and the same thing. Clear? Yes. So this is the notation for first. Now see, y is equal to f inverse x is given to us. Therefore, what is x? If I take f on both sides, f of y is nothing but x. So that is x is equal to f of y. Important things, please see here, everybody. Function always differentiable variable y with respect to variable x. That means left hand variable is differentiated with right hand variable. Whatever may be variable left hand side is given to us, that thing is differentiated with whatever may be variable given on right hand side. So here y2 f. Now x is there, so dx is differentiable with respect to y. That is f dash y. That comes out f dash y. Okay. Now this is the relation. dy by dx is equal to 1 upon dx by dy. We can find derivative of inverse function with help of this standard form. But see, we don't want to prove it. See, consider y is equal to sine inverse x, mod x less than 1. See here I am not writing mod x less than or equal to 1. Of course, in case of inverse trigonometric function, we have to write mod x less than or equal to 1. But we know that function is differentiable only on open interval a. So this thing, and so what we get, x is equal to sine y, and y belongs to open interval minus pi by 2 to pi by 2. Because here equal to 1 is not there, so there is no minus pi by 2 as well as pi by 2. Yes. What is dx by dy? Is equal to derivative of sine y is cos y. Which quadrant is there? Fourth and first quadrant. Cos function is positive. Can I write under root cos square y? Yes. Can I write under root 1 minus sine square y? Yes. Can I write that is equal to 1 minus x square because x is equal to sine y. So what we get dy by dx? Dy by dx is equal to 1 upon dx by dy. So 1 upon dx by dy under 1 minus x square. So if y is equal to sine inverse x, then its derivative is under 1 minus x square. Same way we can find derivative of cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x. Now we are going to write on, of course it's a theoretical part, but as far as board exam is concerned or JEE is concerned, see, or in general 11th, 10th and 11th concerned, 10th, 11th, 12th is concerned, proof of results are not included in board exam. Just we have to see the proof of that result, how we get it. You only know how we get dy by dx is under 1 minus x square, nothing else. So there is no need to learn proof of this one. Please learn standard forms. So let us write all the standard forms in your trigonometric functions. See, let us see. See, d by dx of sine inverse x, that is nothing but 1 upon under root 1 minus x square. Mod x less than 1. But how we are going to remember it? D by dx of sine inverse some function. 1 upon under root 1 minus some function square. D by dx of some function, magnitude of some function less than 1. Suppose we wish to find derivative of sine inverse 2 raised to x. Suppose we wish to find. That is equal to 1 upon under root 1 minus 2 raised to x whole square into d by dx of 2 raised to x. Sine inverse some function 1 upon under root 1 minus some function d by dx of some function. Now what is derivative of 2 raised to x? 2 raised to x log 2 base a raised to some function. A raised to some function log a base d by dx of some function. D by dx of some function, that is dx by x. That is what? 1 upon 2 raised to x square. 2x, sorry, 2 raised to 2x. 2 raised to, in this way we can find it. Yes? Yes. So, now second form What is d by dx of cos inverse x is minus 1 upon under root 1 minus x square mod x less than 1 because of y is equal to cos inverse x. So x is equal to cos y. So dx by dy, what is derivative of cos y? Minus sin y. So here minus sin comes. How we are going to remember it? D by dx of cos inverse something is equal to minus 1 upon under root 1 minus something square d by dx of something or some function and magnitude of some function less than 1. Then tan inverse d by dx of tan inverse x is 1 upon 1 plus x square. X belongs to R. If I take y is equal to tan inverse x, what we get? X is equal to tan y. What is dx by dy? Sec square y. That is equal to 1 plus tan square y. That is equal to 1 plus x square. So dy by dx is equal to 1 upon dx by dy. So 1 over 1 plus x square. Cot inverse, then cot y minus cos x square y. That is minus of 1 plus cot square y. That is minus of 1 plus x square. So that is 1 up minus 1 upon 1 plus x square as far as cot is concerned. Yeah? How we are going to remember this standard form? D by dx of tan inverse some function 1 upon 1 plus some function square d by dx of some function. And that some function belongs to R. Yes? Yes. Next, d by dx of cot inverse x is minus 1 upon 1 plus x square. X belongs to R. How we are going to remember it? D by dx of cot inverse some function minus 1 upon 1 plus some function square d by dx of some function belongs to R. Then remaining two forms. D by dx of sec inverse x. See, y is equal to sec inverse x, so x is equal to sec y. Please see here. Here we have to take mod x greater than 1, and here we have to take y belongs to 0 to pi. Not close interval, open interval, as far as open interval is concerned. So dx by dy is equal to sec y into tan y. So that is sec y. Here plus or minus under root tan square y. Why? In first quadrant it is positive. In second quadrant it is negative. So here plus or minus sec y under root sec square y minus 1 and c plus or minus is there. Can I write mod sec y under root sec square y minus 1? That is mod x under root x square minus 1. So, what is d by dx of sec inverse x? That is equal to 1 upon mod x under root x square minus 1 mod x greater than 1. How we are going to remember it? D by dx of sec inverse some function 1 over magnitude of some function under root some function square minus 1 magnitude of some function greater than 1. Same way, what is cosec inverse? D by dx of cosec inverse is, that is minus 1 upon mod x under root x square minus 1 mod x greater than 1. So we are going to remember it. D by dx of cosec inverse some function minus 1 upon magnitude of some function under root, yes, on
same line. Some function square minus 1 and magnitude of some function is greater than 1. So these are the inverse forms. See, all inverse forms are there. Sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, cosec inverse. Now once again, see, same line here. Starting with C, derivative minus, here also derivative is minus. See, spelling, starting with C, where derivative. So these are the all forms of derivative. In general, if this standard form is known to you, then it is very easy to find derivative. For example, suppose we wish to find derivative. Yes, before this one, let us see working rules of differentiation. That we also know that whenever y is equal to u plus b is given, then what is dy by dx is nothing but du by dx plus or minus dd by dx. That is, sum of derivative to function is same as sum of their derivatives. Same way difference of their derivatives. Clear? So this one is addition rule and difference rule of derivative. Next to y is equal to u, we know it, but even though I would like to recall it, to refresh the standard forms. So what is dy by dx? First function as it is derivative of second one as it is derivative of first one. Order is not compulsory. You can first of all differentiate second function first as it is, then second as it is derivative of first one. No. Okay. So this one is product of two functions. Same way product of three functions also we can solve it. Next, y is equal to division. U by v. What is dy by dx? Denominator quantity whole square, denominator quantity as it is, derivative of numerator minus numerator as it is, derivative of denominator quantity. That is the division rule that we know. Here. So these are the working rules of differentiation. Now please see here. See. Suppose we wish to find dy by dx of sine of cos of 2x plus 1. Here derivative of three functions are there. The composition of three functions are there. How we find differentiate with respect to x. Dy by dx is equal to d by dx of sine cos 2x plus 1. Yes or no? What is the derivative of first one? Sine of some function cos of 2x plus 1 into d by dx of cos of 2x plus 1. Okay. Now, this part as it is, derivative of cos of some function minus sine is there. So write first minus cos of 2x plus 1 into cos of some function minus sine of some function. Minus sine what did we do first? 2x plus 1 into d by dx of 2x plus 1. Now in the last function, and write the derivative last function at last. So what is derivative of this one? Derivative of 2x is 2, derivative of 1 is 0. So minus 2 cos of 2x plus 1 into sine of 2x plus 1. In this way we can find the d by dx of any form. That means if all standard forms are known to us, then it is very easy to find out here. Here. See here. Here what is given? Is function f is differentiable at point C, then it is also to continuous at that point. Means every differentiable functions are continuous.
Now see, if function is continuous at C, so can I write limit t tends to C, f of t is equal to f of C, x tends to C, f of x is equal to f of C, theta tends to C, f of theta is equal to theta C. And then it is continuous. And to show this limit t tends to x, f of t minus f of C is equal to 0. Yes, we can write it. And from this one, limit of constant term is constant. We can write in this way also. Limit t tends to C, f of t minus f of C is equal to 0. Simplified, then you get this one. And therefore, f is continuous at x is equal to C. We need to show this one. Here it is given that function is differentiable at point C. Now d by dx of f of x is equal to limit t tends to x, f of t minus f of x over t minus x. That we know. This is the definition. But d by dx of f of c, derivative at point C, f dash c. Sorry. F dash c is equal to limit t tends to C, f of t minus f of c over t minus c. Call result number 1. Now we want to show that this limit is 0. So start with this limit. Limit t tends to C, f of t minus f of c is equal to, can I write? Limit t tends to C, f of t minus f of c over t minus c into t minus c. Why we are multiplying divided by t minus c? Because this value is f dash c. Give limit to both one. Limit of this part is f dash c and limit of this part is 0. So you get this limit is 0. So it is continuous. So every differentiable functions are continuous. Here, see. So this is the chain rule or derivative composite function. Two functions are given that we can see in this way. See, two functions are there. Derivative first function into derivative second function. Derivative first function. Derivative first function dv by dt and derivative second function d by dx of some function. And see, we skip the proof of this video. We don't want to prove it. The same way, product rule of three functions are there. What is seen that? Sine of cos of 2x plus 1. Clear? In this way, we can do it. See, before moving upcoming lectures, please learn all the standard codes and write it 2 or 3 times to clear it. Clear? Whatever may be things, rest of things we are going to see in next lecture.